Hello, welcome to another AQA A-level Physics multi-choice question. This is on progressive and stationary waves. If you want to choose a different question from the same series, click on the information card up here. If not, I suggest you pause the video now and attempt it yourself. If you got the answer C, well done. If you didn't, here's my explanation. In the diagram, P is a source of a wave of frequency 50 Hz. The wave travels to R by two routes, via P, Q to R, so it can go this way round, or it can go directly to R. The speed of the wave is 30 meters. What is the path difference between the two waves at R in terms of the wavelength lambda of the waves? So the first thing I'm going to do is I'm going to calculate what lambda is, and I'm going to use the equation from your data sheet that the wave speed is equal to its frequency multiplied by its wavelength. Let's rearrange to make wavelength the subject, so that's equal to its speed over the frequency. Speed, we were told, was 30 meters per second, and frequency 50 Hertz. If I put those things into my calculator, I get an answer of 0.6 meters. So that is the wavelength of one of those waves. Now let's see how far it has to travel. If it goes from P to Q to R, it has to travel 20 plus 18 meters. It has to travel 38 meters. If it goes directly P to R, it only travels 30 meters. So the difference between those two is 8 meters. The question is, how many wavelengths? Well, if one wavelength is 0.6 meters, the number of wavelengths is going to be 8 over 6 is going to be 13.3 wavelengths. 13.3 lambda. Answer C. If you found this video useful, hit that subscribe button please. Give me a like, share with friends, and watch more of the same. Thank you.